All right, everyone, we're about to start. The next section is on rational expressions. So everyone done writing this before I move to the next page? Okay. I'll at least get my header going. This is on Math 35. We're doing rational expressions. All right. So a rational expression has the word ratio in it, and ratios are fractions. An expression is like an algebraic expression. So what I'm going to have is fractions with algebraic expressions in them. For example, like x minus 7 over x plus 3. That's a rational expression. We can't use every x here. Not every x works. So we have to list the requirements or restrictions. Why would I say not every x works? And when we did like the factoring stuff, I could put any value for x in, but now I can't. There's at least one value I cannot put in this problem. Anyone know what it is? It's where it makes the denominator 0. We don't want a denominator of 0. Or bottom of 0. So I don't want x plus 3 cannot equal 0. I don't know that we've done any solving of equations yet. I know we've done a lot of factoring and shit like that, but I don't know that we've actually done that. To find out what x can equal, you can either guess and check or do some critical thinking, or if I subtract 3 from both sides, that'll keep things in balance. And I can say x cannot equal -3. This is called a domain restriction. The reason why is what domain means. Domain is all valid inputs. Usually when we're working with it, usually for x is the usual. We often use x as our input variable. And while it doesn't come up here right now, the thing that goes with it is the range. We won't be working with it till chapter 1, I believe. That's all valid outputs. Show me your nails. Are they just dots? What am I looking at? I'm like 15 feet away and I wear glasses. Don't think that I'm going to recognize that as a heart lollipop. I saw a speckled pattern, so I had to ask. All right, so we don't want the bottom to equal 0, so we're going to make notes of it in the future. Another thing that is a rational expression. I could have x minus 7 times x plus 1 over x plus 3 times x plus 1. Now, those of you that are comfortable with fractions will see something on the top and the bottom that we can cancel out. What would that be? The x plus 1s can cancel, right? Before you do it, write down the domain restrictions. So we're going to get x cannot equal -3 and x cannot equal -1. That's my domain restriction. Then cancel. And we're left with x minus 7 over x plus 3. The reason why I say that is usually the only reason you're doing this shit in real life, let's be honest, algebra just doesn't show up for no reason in real life. You're solving some problem that's important. And sometimes you will start with something like this where it does cancel, but -1 is still a problem. And if you cancel it and don't make a note of it, you lose that information. In this case, x being -1 is called a removable discontinuity. I'm not testing you on that, but it will show up later on in like calculus and shit like that. When we're doing graphing, it shows up in graphing when we graph rational expressions. We'll have an asymptote there, or a singularity. But it's important you know that now. Sometimes we don't start in that form. If I give you 2p squared plus 7p minus 4 over 5p squared plus 20p. We want to try to reduce this. If you want a fancy name for this, this is called the fundamental principle of fractions by some people. It's a fancy name, right? That rule says that A times C over B times C just equals A over B. Meaning you can cancel the C's out. It's a fancy rule, fancy name for a pretty trivial thing. So, what does the top factor as? That's the only way we could reduce this is if we factor it. I'm thinking you're gonna come up with 2p minus 1p plus 4. I'm doing a guess and check method here. That looks right. In the bottom, you can take out a 5p and have p plus 4. Which means p cannot equal 0 or -4. Don't ignore this one. This one's an easy one to ignore. Don't ignore it. P can't equal 0. And then if we cross off at that point, then now we can cancel stuff out. And we have 2p minus 1 over 5p. You may be inclined or want to cross off the p's. Just go scratch, scratch. Don't do it. Nope. You can only cancel stuff that's canceling is possible for things multiplied together. Not added or subtracted, like 2p minus 1. And enough people do it that I'm going to show what happens if you do it. So what if you did? If you did. You had 2p minus 1 over 5p. And you cancel the p's off. Some people will go, okay, this is 2 minus 1 on top and 5 on bottom. I should be able to stick in any p that is not 0 and -4 into 2p minus 1 over 5p and get 1/5, if that's true. Well, let's stick in, let's say p equals 10. 2 times 10 minus 1 over 5 times 10 is 19 over 50. And if I were to write this with a denominator of 50, it would be 10 over 50. So these two are not equal, which means crossing off the p's doesn't work. Here. Try to take some time and focus on it in class, because I just fucking cringe when I see it on a test exam. So it like makes me cringe. I see calculus students doing this shit. I fuck with them at that point. Like, you guys should know algebra by now. Come on. Not every teacher's as fun as I am. They'll just be like, now, you should do, be very nice. And I'll be like, really? All right, you guys ready for an example of your own? Okay. Good. Oh, you're typing. The hell is going on here? Sure. Will you ever look at that picture ever again?
Yeah.
Really?
No, I won't.
Because I know as a student, I did that shit all the time. I tried that one time. I'll take pictures of shit I didn't catch in lecture. I never fucking looked at that shit again. Right? How many of you are guilty of this? Take pictures and never lay out. I think of half this class is ignoring me or lying, one of the two, because I think every student's done it. Once cell phones had cameras, it was over. Yeah, I grew up in a world without cell phones. All right, some examples for you guys. Well, I'll give you two. I think this entire section is easier than the fractions or the factoring section. Simply because of all the exponent variations and stuff. I mean, I could include them here, but that's just, even I have limits. Now that I say it out loud though, now that I actually put that thought in my head. Could I put cubics in here? That'd be fun. Some of us are right, some of us are wrong. I'll have a great laugh. Oh, I can't wait till our first test. I used to bring in Kleenex, and now I bring in a tear bottle. Because I'm just that kind of guy. So what you're trying to do is you're trying to factor the top and the bottom separately. And there's no nothing magic going on here. Like the top one is just two terms. You're looking for a greatest common factor. You might have a difference of squares going on, but I don't have any cubics or anything like that. both have a 6, they both have an X. So if I set these equal to 0 and solve, X cannot equal -5/2 or +5/2. Another way of writing this is X cannot equal, and we're going to do plus and a minus sign on top of each other, 5/2. These two things mean the same thing. So if you see plus or minus stacked on top of each other, it means both. And when we cancel stuff out, we will get 6x over 2x plus 5. What did you guys get when you factored this one? Oh, that's about right. What about the bottom?
2x.
I don't know that that works.
After you start off,
4 minus x, right? Wouldn't it be nice though to have the x minus 4? What can I do to make that happen? Introduce a negative. So this is like factoring out a -1. We put a negative here, and we put a negative with the 4 minus x, and the negative with the 4 minus x makes the x positive and the 4 negative. So that's some sneaky shit right there, right? This little trick right here, we'll do this a lot in calculus. So be on the lookout for introducing negative signs. There's two ways to look at it. You can either say I multiplied that by -1 and I multiplied that by -1, and therefore multiplying both is like multiplying by +1, and I can multiply anything by +1 and it doesn't change it. The other way of looking at it is I factored out a -1. So what we have here is x. What can x not equal here? Can't equal 4. Anything else? 0. Once we've addressed that, we can cancel stuff out. And we're left with x minus 4 over -2x. I think that's the least common way you'll see it. We could put the negative on top. I could put the negative inside by switching this around. Or I think the other way you might see it is if you put the negative out front. I think these bottom two are probably the most common. So the next section has got a bunch of shit in it, so maybe we'll pause here. Where we're going next. Next is doing this where we multiply and divide fractions. Divide. Rational expressions, I should say. And I will be at Starbucks at Caldwell and Demery on Sunday morning from 8 to 11. If you want to come, email me, let me know that you're coming, and make sure I make room for you at the table. Have this in map 207. Generally, only a couple students each come, so. And like last week, no one came. On that, have a good weekend. Have a glorious weekend. And don't do anything I wouldn't do. It would help if you knew what that list was, but I'll just leave that up to your imagination. And have a good weekend, folks on Zoom.
Have a great weekend.
You too.